Good afternoon, everyone, and thank you for joining us for this webinar. My name is David Eldridge, and I'm editor of Plastics News Europe. Plastics News Europe is the leading publication for the pan-European plastics industry, published by Crane Communications, which this year is celebrating its 100th anniversary. I'm very pleased that we are able to help facilitate this webinar presented by experts at Mobil on the subject of addressing plastics industry challenges with advanced lubricants. Thank you to everyone that took part in the online survey in January, which has helped form the basis for the webinar today. We'll be hearing more about the results of that survey during the webinar. And we'll also ask you some more questions in some quick poll questions through the webinar. Now, the subject of lubricants perhaps does not always get the attention it deserves. And as speakers, we'll be discussing how important it actually is to use the right advanced lubricants, because of their benefits in wear protection, contamination control, and many other areas. So let me introduce our speakers from Mobil. We have Rakesh Vyas, who joined Mobil in 2010, working in various roles across sales, engineering, marketing, and business development for key European markets. And Rakesh is Field Marketing Advisor.
Hello, everyone. Happy to be here.
And we have David Adams, Field Engineer. He has been with Mobil for 19 years, with a staggered service of 9 years in industrial lubricants in various roles, and is now working in the UK Field Engineering team.
Thank you, David. Good afternoon.
And joining us from Rome is Alessandro Di Maio, Technical Advisor, who's been working at Mobil for almost 20 years, during which time he has worked as Sales Engineer, Field Engineer, Equipment Builder Engineer, and his latest role as an Industrial Product Technical Advisor for Europe, Africa, and Middle East. Hi, Alessandro.
Hi, hello. Thank you, David. Good afternoon and welcome, everybody.
Okay, let's just give you a brief rundown on what the webinar will be covering today. Industry and insights and challenges will be an overview from Rakesh, and then an introduction on lubrication used in the plastics industry, and then more detail on how to select the right lubricant, the role of used oil analysis, and of course the most important thing for everyone, the potential benefits and some real-life benefits in the form of some case studies. We will be finishing after the presentation itself is finished. We'll have a time for a Q&A session. But please, I urge you to submit your question at any point during the webinar using the online function. Whenever a question occurs to you, just write it in that box there and press the submit button, and we'll pick it up here. Okay. So, Rakesh.
Hello, everyone. Thanks, David, for that short introduction. So before we move on to the technical aspects of correct lubrication on a plastics plant, I'd like to highlight and put some scale to the plastics industry in Europe today. So this is an industry that employs just over 1.45 million people today, with approximately 60,000 entities operating across the sector. And that's anything from polymer production to the processing of finished goods, all the way through to the distribution of those goods, the majority of which are small to medium-sized enterprises. With a 320 billion euro turnover, it's one of the largest manufacturing contributors in the EU region, and it's growing, in particular in the packaging subsector. So this is certainly an industry that we at Mobil are interested in today. When we were planning the webinar, what we wanted to do was first understand what the industry is challenged by today. And to do this, I thank our partner, Plastics News Europe, who have helped us to conduct an industry insight survey with a cross-section of plastics professionals who are involved in the manufacturing process of finished plastics goods. The first question we asked our respondents: what's the most important factor when selecting new equipment? So 46% of our respondents told us that the latest technology was the most important factor when selecting their equipment. This was followed by 25% that selected equipment based on energy efficiency. For us, these are unsurprising results, as we know the industry is moving towards higher automation, wider machines, better designs, and we also appreciate that the latest technology and energy efficiency always do inherently go hand in hand. And today we see newer plastics machines embracing that efficiency metric. We also see a lot of new machines that are coming fitted with newer energy measurement instrumentation as well as data loggers. So this is clearly an important area to look at. When it came to lubricant selection, we asked these two questions together. What's the most important consideration when choosing a lubricant, and what is the most important benefit of using the right lubricant? So half the respondents indicated that original equipment manufacturer approvals, as well as their recommendations, influence their choice. And that's certainly something we appreciate in the lubricants business. ExxonMobil today has more than 6,000 approvals for our entire product slate. And our dedicated team of equipment builder engineers work very closely with the key plastics machine makers across the globe, right through from their design stage to their development to the operational stage. 39% indicated price of the lubricant as an important factor. And of course, price will always be an important factor, but alongside this result, it's worth mentioning that the same people indicated that 41% said that productivity gains were the biggest benefit of choosing the right lubricant, and this was closely followed by energy efficiency increases at 25%. This tells us the industry is ultimately looking to lower their total cost of ownership around their equipment, and that can be anything from reducing their filtration costs, improving their cycle times and the units produced, reducing filter and valve replacements, or even reducing the kilowatt-hour input into their pumps, and anything from waste oil reduction. So it's a very vast area that we're looking at here, and it's great to see that the industry is looking to lower that total cost of ownership. Moving more on to a maintenance-related insight, 44% of the respondents indicated that they have experienced equipment wear and failure as a direct result of improper lubrication. 26% experienced oil leakage, and 18% experienced higher downtime of their machines. Again, this was all as a result of improper lubrication. For us, these are staggering results, and they really do act as the main premise behind the next section of this webinar, and hopefully we'll be able to address how proper lubrication can mitigate against these very costly suffering points that plastics processes are experiencing today. So I'll pass you back to David, who would like to now throw a question out to the audience.
Okay, so this is where we'd like you, the audience, to give us some quick feedback on your thoughts on just 3 questions dotted through the webinar. So the first one we're asking you is, can you please select the 2 most important benefits you would expect from your, it says up there, injection molding machine, but obviously if you're not an injection molder, from whatever plastics process you use. So which are the 2 most important benefits you would expect from your machinery? And if you click on 2 of those and then press the submit button, please remember to press the submit button at the bottom right. And this is meant to be just a quick poll, so if we can do that in the next few seconds, and I'll go to the next slide and we'll see what the responses are. Okay, so we have 63.6% of respondents saying no significant downtime with minimum failures is what they're most looking for from their machine. And fairly high as well, 59.1% highest speed in cycle time, nearly 55% saying minimal energy costs, so they're all 3 quite high up there. Then we have mold protection response of 9% of people, and low materials waste from nearly 14% of people. Any comments from Rakesh or David specifically on that?
That's very much in line with the opening statement that Rakesh made on the insights, that there's a lot of interest in productivity and also energy efficiency. So that's quite consistent, and hopefully we can talk about a couple of those issues as we go through.
Okay. Well, we have a comment on this next slide from Hans Ulrich Goltz at one of the leading injection molding machinery manufacturers, Krauss-Maffei, which I'll just quickly read out. In our view, the key requirements of plastics processors in the implementation of the 4th Industrial Revolution are production efficiency, flexibility, automation, availability, and quality. Rakesh, what do you think about Krauss-Maffei's view?
Well, it's not surprising that Krauss-Maffei, a major OEM in Europe, takes this view, I mean, and they're absolutely right as well. You know, plastics processors do need to look at improving their efficiency, and they do that by, you know, achieving flexible production, increasing the availability and reliability of their equipment on site, and they need to do all of this whilst maintaining that quality of their finished good. You know, good consistency between finished good batches as well. And these are all vital to remain competitive in today's market. So totally unsurprising to see Krasmefe's opinion. I would add that these are also areas that proper plant lubrication can have a direct influence over.
Okay.
I mean, if I can sum up some of the insights of the industry and the study that we've conducted here, plastics processors are certainly challenged today, with 60,000 companies in Europe and growing competition coming from outside of Europe. Plastics processors have to look at new ways to survive and thrive in today's market. There's certainly a huge variety of end products on the market today as well, anything from novel and innovative packaging designs to varying qualities and thicknesses of plastics as well. Processors are also having to keep up with increasing customer demands around shorter lead times, lower prices, again, while still maintaining that finished good quality. They have to look at increasing their flexibility around production and mold changeovers as well. We do believe that these challenges can be met by many varying opportunities. And the key ones that we're going to focus on today really do relate to lubrication around the plant. So we'll look at reducing maintenance costs, reducing waste oil, as well as optimizing the running of your equipment with a particular focus on really achieving those productivity and those energy-saving gains that we're hearing from the survey, and overall enhancing your plant safety as well. So I'll hand you back over to David Adams, who will take you through some of the key considerations for selecting the right lubricant and the benefits it can bring to your operations and your bottom line.
Thanks, Rakesh. Thank you very much. And I think I'll probably start with a disclaimer. There's obviously a very broad audience out there today, and this webinar is not designed to be a complete lubrication overview of the plastics industry. We've based on the survey feedback, we've selected a few key areas of lubrication that relate to common suffering points in your industry. So we've tried to keep the content fairly general in terms of different applications, so it's not all about hydraulic oils. And we've also tried to avoid this becoming a chemistry lesson. This diagram provides a good overview of a plastic manufacturing plant. It shows the broad range of applications, all of which require specific types of lubricant. Throughout the whole manufacturing process, lubrication plays a really key role in keeping machines running, conveyors rolling, gearboxes and bearings turning. And as technology's advanced, equipment is designed to run faster and for longer between service intervals. And this often translates to higher loads, higher pressures, and higher operating temperatures. And this, in turn, puts additional demands onto the lubricants. But if those demands can be met, it's realistic to show how lubrication solutions can help show these kinds of benefits that are listed here. And we hope to touch on a few key areas of lubricant selection that have been proven to help customers realize benefits in those areas listed. And we do have some examples later on in the deck. But I believe David wants to ask another question.
Yeah, I think this is a good time for the second of our quick poll questions for our audience. So this is where we want you to feedback to us again. Again, don't think too much about this, just to give some quick answers. But the question is, which are the two major benefits you would expect from the ideal hydraulic oil for your plastics processing machine? There are quite a few answers there, so just select two, and then remember to press the submit button at the bottom, please. Okay, let's see what responses we've got. So coming out on top is 44% of you saying long lubricant life, 40% saying long equipment life, 28% minimize downtime, 28% wear protection, and just skipping one there, energy efficiency also 44%, quite high, and valve cleanliness and long life performance is 8%, and environmental friendliness 4%. Okay.
I'm encouraged by that. Hopefully we can touch most of those points. So this slide, it's whether we're referring to a gear oil or a hydraulic oil or a compressor oil, the primary function of a lubricant is to reduce friction. So, however, there are many other physical and chemical properties that are essential in a lubricant, and those are different for each type of lubricant. A selection of these are listed in the diagram above, and it is just a diagram. It's not designed to represent an actual product. But the point we want to make is that you need a lubricant that is strong in all of the key properties that are essential for that particular application. It's not, as is sometimes the case, strong in a few key areas, but at the expense of poor performance in another. And you also need a lubricant that's going to retain those characteristics throughout its service life. To achieve both high performance and longevity requires a balanced formulation using base oil and additive combinations that work really well together, and they stick together through the good times and the tough times. It is just like a marriage. The first, and we refer, when we talk about a lubricant having a balanced formulation, that's what we're referring to. And the first lubricant property that I'd like to cover is high viscosity index. So most machines and equipment today are designed to operate within a certain operating window, and temperature is just one parameter that can define an operating window. For example, a plastic injection molding machine is designed to operate on or around 50 degrees centigrade. Across all the different types of equipment, operating temperatures can vary enormously, and according to the workload, the production shifts, the speeds, and also the efficiency of the cooling systems on each piece of kit. So we know that the viscosity of an oil changes with temperature, and the rate of change is quantified as its viscosity index. And it's illustrated by the gradient of the line, of this blue line. And this represents an oil with a normal viscosity index. And if we consider the temperature range on the x-axis as a theoretical operating window, at the lower end, the oil is cooler and the viscosity is higher. This makes it harder to move the oil, which means expending more energy. At the upper end of the window, the temperature is higher and the viscosity is lower. And we know from lubrication theory that a reduction in viscosity will lead to a reduction in film thickness. And at some point, a reduction in viscosity will result in wear, where you have metal-to-metal contact. Now, if we compare this oil with an oil that has the same viscosity grade but has a higher viscosity index, we see that over the same operating window, the oil is less viscous at the lower end and more viscous at the upper end, and the gradient is less. So you can see the benefits of choosing a lubricant with a high viscosity index is increased wear protection and improved pumpability. And this then has a positive impact on maintenance costs and energy consumption. The next area is high pressure operation. So we've just seen and covered the virtues of using a lubricant that has a high viscosity index, and you'd certainly want the oil to retain this property throughout its service life. The oil in a hydraulic system is subjected to such high compression and shear stresses that with some hydraulic oils, the viscosity index improver additives are susceptible to shear. The result of this is that viscosity drops, and it's a form of degradation. And if you were to, as an example, you could check the viscosity index of an oil at the beginning and at the end of its service life, and it would give you an indication, if you compare the two, it would give you an indication of its shear stability. So in choosing a lubricant with a high viscosity index, it is just as important that it is shear stable. And this is achieved by, again, developing the right combination of a high-quality base oil and additive. The next area, 44% of our survey respondents reported issues with component or equipment wear, so this is very topical. So if we're working with a customer who's reported issues concerning wear, the first and foremost consideration aspect of controlling wear is to choose a lubricant with the correct viscosity for that equipment's operating window. So it's the first thing we would check in an application. However, there are times when metal-to-metal contact does occur, and so the second line of defense, if you like, is a surface-acting anti-wear additive. And there are essentially two different types of anti-wear additive. There are those that contain zinc and those that don't. The zinc-containing additives, they work well, and they've been used for a good number of years. But under severe operating conditions, they have been linked to the formation of sludge, which in a hydraulic system is not a welcomed guest. A zinc-free anti-wear additive can provide the same level of protection, but are less susceptible to sludge formation. So our recommendation is that if you're experiencing issues around sludge formation using a zinc-containing additive, then you should consider the zinc-free option. So the next aspect is oxidation control. It's an unavoidable fact. Lubricants oxidize over time. The rate of oxidation depends on several factors. Temperature is the main one. So what are the effects of oxidation? Well, there are the visible effects, such as being able to see through the sight gauge that the oil is becoming darker. And although you can't see it, you can detect an increase in viscosity. It's the invisible effects which are the more harmful to your system, and they are the byproducts of oxidation which contaminate the oil, and this leads to a number of problems, and some of them are listed here. So if the oil has not got good oxidation resistance, you may see symptoms such as filter plugging or varnish formation. And again, it's the right combination of having a high-quality base oil that, in this instance, has a natural resistance to oxidation and the use of an antioxidant additive to give you an oil with good oxidation resistance, and it can protect your equipment over extended oil life.
Okay, this will be our last snapshot poll that I'm asking our audience to take part in. This one's a little bit different in that we're asking you to come up with an estimate, and that is what estimate percentage you consider to be of all failures in injection moulding are caused by hydraulic oil contamination. So this is just a quick guess, if you like, or maybe educated guess if you think you know. So just click one of those percentages and then press the submit button, and we'll see now what the responses are. Okay, so the most popular answer is 60% from 39% of you, and then it's 40% from 32% of you, and then we have 80% from 16% of you, and 20% from 12.5% of you. Okay, well, when the American Plastics Council did this question, did a survey on it, they found that it was actually 80% of all failures in injection moulding are caused by hydraulic oil contamination. David, does that sound right to you?
Well, you're all pretty close. There's a high recognition of the effect that contamination can have into a lube oil system. So contaminants in a lube oil system, unfortunately, are almost unavoidable. You typically get dust, you get water, there's processed materials coming from outside the system, and you also have wear debris and contaminants which are generated from within the system. And like oxidation, contaminants compromise the life of the oil. And also like oxidation, it triggers many other ways that the oil degrades, which ultimately leads to equipment failure. So it's really, really important to be able to remove those contaminants easily. And this is the job of the filters. The oil can either make this easy or difficult, and an oil with good filterability allows the oil to easily pass through fine filtration mesh, and at the same time give up the contaminants that have been held in suspension. It's stating the obvious, but it's good to choose an oil that has good filterability. And if you are experiencing short filter life, then you could consider a lubricant that offers better filterability. So we've covered the concept of having a balanced formulation that delivers good performance in a number of areas, and this is achieved through the right combination of having the high-quality base oil and additive pack. And I'm going to hand over to Rakesh, who's going to take you through a few of the product ranges that exemplify these characteristics that we've just covered. Rakesh?
Okay, thanks, David. So you've heard from David what to look out for when selecting the right lubricant and why. We've heard that if you are experiencing some of the issues that he's mentioned, some of the areas that you could consider when selecting a better lubricant. And we've talked about that balanced formulation, temperature performance, wear protection, oxidation and contamination control. They're all very important parameters to look out for. I'd like to take a moment to just highlight to the audience some of the products that ExxonMobil leads this industry with to meet some of the challenges that plastics processors face today. So the first product is Mobil DTE 10XL. This is our leading hydraulic oil. This is a product that has that high viscosity index. It's been proven or can help to achieve up to 3.6% energy efficiency saving when compared to an equivalent standard mineral oil. It has ultra keep clean performance, which helps to control the oxidation and contamination. Now, all of these can have a direct effect on oil change intervals, on filter and valve replacement costs. They can help to reduce machine downtime, as well as help to reduce the number of pump failures that you have. Mobil SHC Raris is our product for air compressors. This is an oil that we have seen lasts 3 times as long versus the leading competitive synthetic compressor oil today. And this, again, really does help to reduce your oil change intervals and waste oil. And it's a product with that wide temperature performance range. Finally, Mobil SHC 600 circulating oil. Again, that wide temperature performance range that we have. It's a product that has fantastic wear protection, in particular for highly loaded bearings and gears. Something that really underpins our products in the plastic sector is that key relationship with OEMs. And this is a relationship that's lasted over 100 years, and it's something that we leverage and demonstrate value to with our customers to solve some of their key lubrication challenges. So we've covered off a few areas, things that you should look for in your lubricants used on site. But as we know, it's not all about the lubricants. I'll pass you back to David now, and he's going to demonstrate some of the other areas that you should discuss and actively search for when you talk to your suppliers today.
Thanks, Rakesh. No, it's, as a leading lubricant supplier, we don't just supply products. We work closely together with our customers to understand their business and operational needs, and we leverage all the available technical resources and services to develop cost-saving lubricant solutions. The 4 areas there shown on the technical support, for example, Rakesh has already referred to the long-standing history that we have with our equipment builder network, and that's just one area of technical support that we can tap into. We have a very strong field engineering services team across Europe, and the engineers in those teams work exclusively on customer projects, looking at developing lubrication solutions, helping them to improve productivity and reduce their maintenance costs. And they work very closely with our trained sales representatives. And the last aspect, the 4th aspect there shown is, if we're talking about a lubrication solution, it's difficult to avoid the subject of oil analysis because it is so important. So if we'd like to, there we are. So we'll talk about a little bit about used oil analysis. We have to treat lube oil as the lifeblood of your equipment. And by analyzing the oil at various intervals, it's possible to get a health check on the condition of the oil and also of the machine. We can pick up gradual changes that occur over time, and it provides really useful insights into what is happening inside your equipment. It supports a predictive maintenance program, and it helps you to get the most out of your oil, which I think was one of the things that came up in the surveys. It's certainly worth putting into place a conditioning monitoring program for your critical equipment. So my advice is don't wait for something to go wrong, because it will when you least expect it. Give yourself the benefit of foresight and put in place a condition monitoring program for your critical equipment. Protect your business with Signum.
Okay, so we're now looking at the real-life benefits with looking at some specific case studies.
Okay, yeah. Everything we've mentioned so far has been really around the potential benefits and the theoretical benefits of good lubrication. So what I'd like to do now is really take you through some examples of where our products have succeeded in the real world to meet some of these challenges. So I've got 4 examples prepared for you, 4 case studies, and as you can see, they're examples from manufacturers across the globe, from varying sub-industries, and I'll go into each one in just a little bit more detail to give you a flavor of the kind of case studies that we have to show. So, in China, we have helped a major plastics component manufacturer on their PVC calendar machines. We've used our Mobil SHC 636 product, which is part of the Mobil SHC 600 series I talked about earlier. And this really helped to achieve up to 4 times longer oil drain interval versus their previous oil in use. The customer also experienced a relatively large increase in their availability of their machines, lowered maintenance costs, lowered filtration and oil disposal costs, and all of this equated to an annual saving of over $130,000 per annum. This is verified by the customer and a great result that we were able to help them achieve. The second example is with Volkswagen Audi. A plant they have in Germany uses 22 injection molding machines, and these are a mixture of Kraus-Maffei as well as other OEMs. And we were able to demonstrate an energy saving between their previously used oil, the HLPD 46 ISO-VG grade hydraulic oil, versus our Mobil DTE 10XL. This energy saving equated to 3.7% annual saving. That's the equivalent of 330,000 kilowatt hours per annum saved on electricity input to that plant. They also saw an extension in their oil drain intervals and an increase in their system service life. I mean, these are 2 areas that have been highlighted through not only the survey but the live polls that we've had today as well. Again, another great result where we were able to help our customers achieve their business goals. An example now where we've really achieved success with our solutions and products as well. Hafner and Krallman, a major company based in Germany, they specialize in plastic spools, and they currently have more than 50 injection molding machines in operation on this one site, all varying in sizes between 50 to 2,000 tons. The company is one of Europe's largest manufacturers of plastic spools, and they range from special spools for silver stripes used in €100 notes to the spools produced under clean room conditions for medical equipment and applications. So this company has realized the importance of hydraulic oils in maximizing the productivity of its equipment for a number of years, and was really keen to see what performance benefits could be realized through the introduction of Mobil DT 10XL. So following a successful test phase with 2 machines, the company have decided to convert their additional machines to Mobil DT 10XL. Since then, 5 of the company's installations globally have been filled with Mobil DT 10XL, and the other machines it's being used for top-up purposes until they have a complete refill. So, following the initial introduction, initial monitoring of Mobil DT 10XL, Hafner and Krallman stated they can extend their oil drain intervals from 40,000 to 60,000 operating hours, making an energy saving of up to 2% on average across their machine portfolio. This company also expects to double their filter life, which in itself would deliver significant cost savings. So these are results that the customer is verifying and telling us. The last example I'd like to share with the audience is really around our premium range of greases that have helped a plastics manufacturer in the US in their Husky injection molders. So using Mobil SHC Polyrex 005 grease, a polyurea-based grease, we were able to achieve a 200% increase in the life of their tie bar shoes. This customer has documented this saving to be worth over $100,000 per annum. They also anticipate they will see an increase in equipment availability, reduce their oil consumption, and a lowered maintenance and oil disposal costs. These advantages also come about in the fact that they'll have less human interaction, less maintenance engineering interaction with their machinery and with the oil, and therefore this also delivers some safety benefits to the site as well. I mean, it's worth mentioning that we have many more examples and an extensive library where we've been able to help our customers with our solutions to meet some of their challenges as well. I'll now pass you back to David, who's going to summarize the main body of the webinar, and then we'll open the floor up to live questions.
Thanks, Rakesh. It's just a really brief summary. We've tracked how the challenging environment in the marketplace has translated into those specific manufacturing challenges for yourselves, and how that has put the extra demands onto lubricants. We've covered the concept of having a balanced formulation that gives excellent overall performance over the service life of a lubricant, and also the importance of leveraging our knowledge and support services to provide true lubrication solutions that can help improve productivity, reduce costs, and offer energy efficiency savings. And that's it.
Great. Well, thank you very much, Rakesh and David. Very informative and interesting presentation from you both. This is a chance for the audience now to get involved with some questions. If you haven't already submitted a question during the webinar, you can still do so. And I'm going to bring in now Alessandro Di Maio, who's in Rome, and he'll be answering questions in some more detail. Alessandro, can you hear me okay?
Yes, I'm fine. I can hear you.
Great. Okay, here's the first question. What are your thoughts on hydraulic oil leakages? It's a common problem for us. Is there a way to avoid it?
Well, regarding oil leakages, you should know that oil leakages may have some different root causes, which may be related. Some of them may be related to the equipment, some others may be related to the oil itself. Leakages may lead to pressure drop, ingress of contamination like dirt, dust into the system. And of course, if you have these leakages in your plant, you may increase the safety risk and operational cost due to low performance efficiency. Of course, leakages may have negative impact to the production quality and reliability of the system. In case leakages are related to poor oil performance, there is a relationship because one of the functions of the lubricant is also to act as a seal. So if it loses viscosity or it loses properties, maybe not any more able to act as a seal in the system. So did I answer your question?
Okay, thanks a lot, Alessandro.
Okay.
Okay, another one for you. What are the applications where high-performance lubricants can deliver benefits?
Well, if we are talking about in the industrial application, high-performance lubricants give the best benefit in modern equipment, where you see that there is higher stress, higher load. The systems tend to be more compact, which means that pressure are much higher. Residence time is much smaller. Residence time is the time that is given to the oil to rest in the reservoir, just to separate water, air, whatever. So moving towards new technologies in the industry application, especially in hydraulics and in plastic sector, you will benefit by using high-performance lubricants because these products are designed to face this type of challenges.
Great. Okay. Another question is, how important is it to keep the hydraulic oil clean from particle and water contamination?
Well, as David said before during the presentation, solid particles, generally speaking, contaminants are really harmful for the system. Some of them are generated into the system itself, like hard particles or wear particles, and some others may be introduced accidentally into the system, or it may be part of the working environment, so moist, humidity, and so on. It has been demonstrated that especially hard particles contamination is one of the main causes of equipment failures. So having a product which has a good filterability, so which reacts quickly to contamination by separating these contaminants and bringing them to the filter, will help to have a more efficient system.
Great, okay. And here's another question. How can I check if the oil is working properly and my equipment is in good conditions?
You may use some kind of services. We usually suggest you use some kind of services that are called routine monitoring. Basically, taking a periodic sample of the oil and sending that to a specialized lab, you may have very useful information regarding the oil condition. So if the oil is working properly, if there is some thermal stress, or if there is abnormal depletion of the additives, or some contamination occurring in the system. You may have also as well some very important information about wear metals. You have a list of wear metals that reported in the routine analysis report, and those wear metals are linked to specific parts of the hydraulic system. So you may have both information about lubricant and equipment condition.
Okay, just a reminder to the audience, if you have questions, you still can send some in to us. Just remember to press the submit button. Okay, here's another question. How can Mobil lubricants improve the material efficiency? I think that was something that came up earlier.
Material efficiency or equipment efficiency?
Material efficiency.
This is like filter costs.
Is that, yes?
So probably this is more linked to TCO, so total cost of ownership, probably. So basically, if you have a product which has a very good performance and has been designed to deliver some kind of specific performance in terms of cleanliness and equipment protection, this has a direct impact on material cost because maintenance costs are much lower due to the fact that you're using much less material. The most popular example is filters, but also valves or pumps spare parts, which have a very big impact in the overall cost of running a kind of equipment.
Alessandro, do you have a minimum micron rating filter you would recommend for sophisticated pumps and valve systems for the Mobil Dite 10XL lubricant?
Well, Dite 10XL is a high filterability product, so there are no specific minimum level of filtration. Usually what we do recommend is to stick to OEM recommendation. Usually OEMs, they used to recommend some kind of minimum filtration, but with the most advanced system, I have seen, for example, 5 micron or down to 3 microns, for example, on Moog valves. These are the requirements. But this is not, a limit for Dite 10XL. It is easily filterable, even at this very low filtration limit.
Okay. Here's one question, Alessandro. How can we identify the level of oxidation in used oil analysis?
It is a combination of factors. One of the most important one is the acid number. Every number is linked to the overall, let's say, life quality of the oil. So it has some value at the beginning, and this value tends to change during the lifetime of the oil. An increase in TAN may be an indication of oxidation of the lubricant, but this parameter should be evaluated also in combination with other ones like viscosity, for example, because viscosity and TAN in combination give a good indication of oil aging or oxidation.
Great. Thanks a lot, Alessandro. I think it's probably about time we, I think, wrapped up now. Sorry if we didn't get around to actually asking your question during this Q&A session. But if you do have a question now or at some point in the future, there's some email addresses that you can send your query to. But in the meantime, I'd just like to say thank you once again to Rakesh, David, and Alessandro, and I'd like to also say thank you to all the people who participated in the audience. Thank you very much.
Thank you.
Thank you very much.
Thank you. Thank you.